Assalamu-Alaikum everyone. I'm Hamiza Gul Zainab, and today my topic of presentation is 3D bioprinting of human organs. First of all, I want you to imagine that a patient is told that their kidneys have failed and they need a transplant to survive. The patient joins a waiting list, hoping a suitable donor will be found. Days turns into months and months turn into years. Now, imagine a different future. Instead of waiting for a donor, doctors take a sample of patient's own cells and use a specialized printer to create a replacement organ. It sounds like something from a futuristic movie, but this is the vision behind 3D bioprinting. And today, I'll take you into the fascinating world of 3D bioprinting and explain how scientists are working toward printing living tissues and organs that could transform modern medicine. The question arises, why is it needed? Before discussing the technology, let's understand the problem. And the problem is that every year, thousands of people require organ transplant, and unfortunately, there are simply not enough donor organs available. Many patients spend years waiting for a suitable donor. Some patients never receive one. And even after a successful transplant, another challenge appears, which is organ rejection. The body's immune system may recognize the new organ as foreign and attack it. As a result, scientists began asking an important question. What if we could create organs instead of waiting for them? And that became the driving force behind bioprinting research. Now, the next question arises, what is 3D bioprinting? Think about a normal printer. You send a document to the printer and it places ink on paper to create text and images. Now imagine replacing that ink with living cells. That is essentially the basic idea behind bioprinting. 3D bioprinting is a technology that uses living cells and biological materials called bioinks to create tissue structures layer by layer. The printer follows a digital blueprint designed on a computer and carefully places cells in precise position. And the result is not a plastic object, but a living biological structure. This technology brings together biology, engineering, medicine, and computer science into one revolutionary process. Now, if we look at the history of 3D bioprinting, then the story of bioprinting began with traditional 3D printing in the 1980s. At that time, printers could only create objects from plastic and other non-living materials. Then scientists realized that if printers could place plastic in specific patterns, perhaps they could also place living being cells in specific pattern. So, in the early 2000s, the first bioprinting experiments began, and over time, researchers successfully printed skin tissues, cartilage, and blood vessels. And today, scientists are working towards something much more ambitious, creating complete functional organs. So, what started as a simple idea has now become one of the fastest growing fields in biotech. The next thing is 3D printing versus 3D bioprinting. Although their names are similar, these technologies are very different. Traditional 3D printers work with materials such as plastic, resin, and metal. On the other hand, bioprinters work with living cells. Traditional printers create products like machine parts, tools, and prototypes, while bioprinters create living tissues. We can say that one produces objects and the other produces biological structures capable of growth and function. And this difference makes bioprinting significantly more challenging and far more exciting. The next thing is components of bioprinting system. Now, creating living tissue requires several important components, and the first is bioink, which acts as the raw material. Bioink contains living cells suspended in supportive biomaterial. And the second component is the cells themselves. These may be stem cells or cells obtained directly from a patient. And the third component is computer software that converts medical images into three-dimensional blueprints. And the fourth and the final component is the bioprinter, which carefully deposits the bioink according to the digital design. And together these components function like a highly advanced biological construction system. The next question arises, how does it works? Obviously bioprinting. The process begins with medical imaging. For doctors use CT scans or MRI scans to obtain a detailed picture of organ. Next, scientists create a digital 3D model using specialized software, and the printer then follows the blueprint and deposits bioink layer by layer. At this stage, the structure resembles tissue but is not yet fully functional. Therefore, it is placed inside a bioreactor, which acts like an artificial environment providing nutrients, oxygen, and ideal growth conditions. And over time, the cells grow and organize themselves into living tissues. Now, the next thing is types of bioprinting. Scientists use different printing techniques depending upon the tissue they want to create. One of them is inkjet bioprinting. It works like a household printer and deposits tiny droplets of cells. The next is extrusion bioprinting. It pushes bioink through a nozzle similar to squeezing toothpaste from a tube. And the third is laser-assisted bioprinting. It uses laser energy to position cells with remarkable precision. Each method has its strengths and weaknesses, and researchers select the most suitable one for each application. The next thing is advantages. Now, benefits of bioprinting are enormous. It could reduce the shortage of donor organs. It may allow personalized organs to be created using a patient's own cells. And this would significantly reduce transplant rejection. Also, bioprinted tissue can be used for drug testing, helping scientists develop safer medicines. Researchers can also study diseases more effectively without relying entirely on animal testing. So, in many ways, bioprinting has the potential to change the future of medicine. The next thing is current applications. Although complete organs are not yet available, bioprinting is already making a difference. Scientists have developed artificial skin for burn patients. Cartilage tissues are being used to help repair damaged joints. Researchers are also exploring bone regeneration and tissue repair. Also, bioprinted organoids are helping scientists understand disease and test new treatments. These applications demonstrate that bioprinting is already moving from theory to practice. Now, the next question arises, and we all know that all of us want that question to be answered. And the question is, can we print complete organs? The short answer is not yet. Researchers have successfully printed heart tissues, liver tissues, lung tissues. However, creating a complete functional organ remains extremely challenging because human organs contain millions of cells arranged in highly complex patterns. Despite these challenges, scientists continue making remarkable progress every year. If we look at the challenges, then, like every emerging technology, bioprinting also faces challenges. One major challenge is creating blood vessel network capable of delivering oxygen as well as nutrients throughout the tissue. The reason behind this is blood vessel networks inside human organs is a very complex network, and it is very hard to establish that network artificially in a lab, but scientists are still trying to figure it out. Another challenge is maintaining cell survival during printing. Now, the reason behind cell survival problem is that human cells are the cells that can't be maintained under normal lab conditions because they require a specific nutrients, specific gas level, and specific condition. If these conditions are not met, then they may die. So that's a challenge. The next thing is the equipment used for bioprinting, and these equipments are very expensive. And also, to operate those bioprinters, experts are needed, and which, of course, in today's world, there are not much experts that can operate these machines efficiently. In addition, strict safety testing must be completed before printed organs can be used in patients. These challenges are significant, but researchers are actively working to overcome them. The next thing is future of 3D bioprinting. The future possibilities are extraordinary. Imagine hospitals producing personalized organs on demand. Imagine patients no longer waiting years for life-saving transplants. Or imagine safe drug testing, faster medical research, and more effective treatments. Although these goals have not yet been fully achieved, every breakthrough brings us closer to that future, and the next generation of healthcare may be shaped by technologies like bioprinting. In conclusion, I want to say that 3D bioprinting is much more than a specific innovation. It represents hope for millions of patients suffering from organ failure. And by combining living cells, engineering, and advanced technology, scientists are creating solutions that were once considered impossible. Although fully printed transplantable organs are not yet a reality, progress made so far suggests that 3D bioprinting could redefine the future of medicine. What seems impossible today may become routine medical practice in the coming decade. So, thank you very much for watching, and I hope this presentation has given you a deeper understanding of science applications, challenges, and future potential of 3D bioprinting of human organs. Thank you very much.